Okay, this lesson is 41-2. It's on the conditional probability formula. It's going to be only one video. I'm going to do the whole thing. It's pretty short. So, we're going to go over here. I've copied the work over here for problem number 1. It was on a couple of different pages. So, notice that they have tortoises again and the known gender. Notice that they've got the number of tortoises total down here and the number of known gender total down here. I believe there was a total of 91. Is that right? If we do 4 plus 20 plus 37 plus 30, yeah, that's a total of 91. So inside this Venn diagram, there's a total of 91. Okay, so write each probability as a fraction. I don't really understand why they want us to write it as a fraction. It'd make just as much sense to write it as a decimal. But okay, find the probability of a tortoise given that we know its gender. Okay, its gender is known. So the known gender, the total known gender is what's going to go on bottom. So that's 57. And the fact that it's a tortoise with its known gender. So that's going to be 20 on top. I'm going to jump over here and just make sure. Yeah, given that it's a known gender, I'm right. Okay, now it says find the probability of the fact that it's a tortoise and it's known. That's this piece right in here. So that's a total of 20 out of 91. And next they want me to find the probability of just that it's a known gender. So that's 57 over 91. Now it wants us to do this. This answer right here, they want us to make a fraction, and they want us to take this answer. Here's this answer right here. And they want us to put it on top. So I've got 20 over 91 on top. And then they want us to take this answer right here and put it on bottom. 57 over 91. And they want us to say, okay, what do you notice? Well, this is a fraction. Here's the main fraction. And remember, all fractions are just division problems. So we've got a fraction being divided by a fraction. Do you remember what you learned for your fraction rules? Keep, change, flip. Do you remember those? This problem right here is the same thing as saying 20 divided by 91 divided by 57 divided by 91. And we keep this fraction the same. We change that to a multiplication problem and we flip this upside down. And now we multiply. The 91s cancel out and we end up with 20 over 57. So they want us to notice that the answer to this problem right here is the exact same answer to this one. So they want us to notice that the probability of tortoise given that you know its gender is equal to the probability of tortoise and known gender divided by the probability of a tortoise. And why? Why do we need to know this? Because they don't always give us our total numbers right here. They often give us just the probabilities of things happening, and this will make it easier not knowing the actual count of what's happening. So this is the formula that they were going to give you, or that they told you were going to learn. So when you go back over here, it says develop the conditional probability formula. We just did. So the formula that we learned is this one right here. For any two events A and B, the probability that A, given that B has already happened, is the probability of A and B happening divided by the probability of B. So the known right here goes on bottom and their intersection goes on top. So it's the intersection, which is exactly what we've already learned which is exactly what we did when we did this right here. The known was this total amount right here. This was the one that went on bottom, and then their intersection is what went on top. So what's going to be different now, because that's your whole lesson, there's nothing else for me to do except go over the check your understanding and the lesson with you. And so that's exactly what I'm going to do. But before I tell you to stop the video and try to do these, because I don't want you to watch the whole video, I want you to try to do these. I want you to notice down here that they did not give you an actual count. Down here, they changed it to, this is the probability of the tortoises. So this is, it looks different, and that's okay. It's going to work out. You're going to work it the same way. They just give you the probabilities right here. So you get to skip the fraction part, okay? So stop the video now and see if you can't do this section, and I will go over the answers with you when you start the video again. But stop the video and see if you can't get these answers. Okay, so I'm assuming that you've given it a try. Like I said, these are the percentages, the proportions already worked out. I would sometimes suggest go ahead and adding these two together. So the probability of getting a tortoise is, what is that, 0.67? And then the probability of the gender not being known is 0.48. And then this is not a tortoise and the gender is not known. And by the way, if you add all of these pieces up, it equals 1, which is the probability should always add up to equal 1. Okay, so write the probability of, this is not tortoise. What was this? Temerian? I don't know what that is. It's an animal, I guess. What is the probability that a randomly selected primate is a Temerian and is at least 9 years old? Oh, and that means 9, not known. I guess I should read the problem. Here's the and part right here. Okay, so there's how you write it using probability notation. The probability of Terrian and at least 9 years old, that's 0.27. It was gotten, you get it right off the Venn diagram. What is the probability the randomly selected primate is at least 9 years old? That you take the total of the 9, which is 0.48. So you take those little two pieces right there, the ones that are a Temerian and the ones that are not Temerians, add them together, that's 0.48. And now what's the probability that a randomly selected primate is a Temerian given that it's at least 9 years old? So Temerian given 9 years old. The 9 years old goes on bottom, the intersection of the two goes on top, and then because there's math to do, you should do it, and that should have been the answer that you got. Okay, let's go over here and check your, I'm supposed to tell you if you haven't already, stop the video, go try to do these problems right here, and then finish the video by checking your work. So stop the video and work on these problems. Okay, so basically they give you the information right here. The probability of female is 0.39. And so the probability of female is 0.39. 54 are at least 8 years old. So they use E to stand for 8. So the probability that they're at least 8 is 0.54. They just move the decimal. And then 21 of them are females who are at least 8 years old. That means they're female and they're 8 years old. So that one was also given. That's 21%. Okay. Then they want us to put that in a Venn diagram. So this is the hard part, because you have to understand that they did it differently than we've done it, like on this one over here. So here they've given you 0.21 and then they've given you the total. So you have to calculate what's in here. So 0.21 is part of this total. So just because I'd like to be able to, you know, write down what I'm going to go ahead and do the math right here. So 0.39, take away the 0.21, and this part right here is 0.18. So if you put these two together, you get the 0.39. And again, if you put these two together, you should get 0.54. So 0.54 minus 0.21, you get 0.33. So 0.21 is the number of females and at least 8 years old. That means this is just the number of females that you have that are not at least 8 years old, which adds up to be the total percentage of females, the total percentage of at least 8 years old. So we've got it divided up now. And then part C, when a lemur is selected at random, what is the probability that it's female given 8 years old? Female given 8. So female given 8, they want us to use the formula. It's this number on top, given the total number of 8 on bottom. We get that divided out. The next one is when a lemur is selected at random, what is the probability that it is at least 8 years old, given that it's female? So we're finding the probability that it's 8, given that it's female. So we've switched these. So this time the total number of females goes on bottom. Females goes on bottom. And then the intersection of those two, out of these, the number ones that are female or that are 8 go on top. And then you do the math. And then E, when a lemur is selected at random, was probability that it's either female or. Now there's a typo in the guide, in the solution, the teacher's edition. Or should be, this is the symbol for or. This is the symbol for and. So it should be the probability that it's female or 8. Okay, and that means that we basically just add these 3 numbers together, because that's female, that's female and 8, and that's just greater than 8. So you just add those 3 numbers together. Now look what they did. They added these 2 numbers together. Now what's wrong with adding those 2 numbers together? If you add 0.39 together with 0.54, you've counted this 0.21 twice. Because when you add the 0.39, you've added all of those. When you add that to the 0.54, you've added all of those. So you've stuck that 0.21 in there twice. So we got to take it out. If you just add this one and this one and this one, you still end up with 0.72. Okay, then they give us a new Venn diagram and they want us to use this diagram. I went ahead and added those 2 together just so that you could see the probability of R and the probability of Q. It wants to calculate the probability of R given Q. So Q goes on bottom. So see, it was good that I calculated that 0.44. And then the middle piece right here goes on top. So that's 0.36. And you calculate that, and there it is over here. Construct an argument. What is the probability that the player is a pitcher given that he is right-handed? Okay, so 0.82 is right-handed, and then 0.36 is right-handed and a pitcher. And it says this probability assumes that we already know that the player is right-handed thrower. The other probability simply tells us how likely a random selected player from the entire roster is to be both a pitcher and right-handed. Okay, so read that again and let that sink in if you need to. if a right-handed thrower is selected, what is the probability that he is not a pitcher? Okay, so this is the given. This right here is given. So notice that the 0.82 goes on bottom. And then the not right-handed, so I mean, if this is, what is the probability that he is not a pitcher? If this is not a pitcher, then this over here is the ones that are right-handed but not pitchers. So that one, that's what goes on top. That's the complement of not a pitcher. Okay, the reason you don't include this one right here is because this one is not right-handed. Okay, so we have to include only the ones that are right-handed. So this number right here, 82, goes on bottom. If a player who is not a pitcher is selected, okay, this is our given. Given that not a pitcher is selected, so where did the 0.56 comes from? That's the given part. That's not a pitcher. See, this is what it, not a pitcher. So we've got, these are the pitchers. So we need 46 right here and this one. These two have to go together. So if you do 0.46 plus 0.1, then you get 0.56. So that goes on top. So this is the given. We know that happened. Now here's the probability that they're wanting for. What's the probability that he's a right-handed thrower? So you put the 46 on top. You can't include the 36 because that's a pitcher, and we said not a pitcher. So this is right-handed that are not pitchers, and this is the total number of not pitchers, and that's how you would write it. And that is the end of this lesson.